I would like you to also look at p-value from a more practical stance. That is, in the field of research. If you are doing research in social science, if you get a p-value less than 0.505, if you get this p-value in social science, it can be accepted. That's a standard. But if the p-value is greater than 0.5, it cannot be accepted. What this is saying basically is a chance of 5 out of 100. So if when you run your statistical tools or software to do your analysis and you get a p-value of anything bigger than 0.05, then there are going to be a lot of questions surrounding that. You should get a p-value less than 0.05. For example, of p-value equals 0.02 would be a little bit nice value. In essence, what this is saying is that in the research that you have conducted, the actual chance of getting the value that you have gotten, or in other words, getting the values on a chance, is on a chance of 5 out of 100, which is not bad. So that is somewhat accepted. Had it been a chance of 20 out of 100, that would be definitely too high. If we do the calculation, we get 0.2, which is actually higher than 0.05. Okay? So the p-value, in essence, gives the acceptance range. Again, we're going to go back to the normal distribution. So the p-value practically is used in this sense, or can be used in this sense, where we have here to be the null hypothesis. So that's the null practical, in practical research. For example, quantitative research, you will have to set up a null hypothesis. So this is null hypothesis. And this region here is the alternate hypothesis. What the alternate hypothesis is to say that there exists a difference. For example, if you have a class of students and you are using an intervention program to see if the intervention program impacts learning, the students who are not exposed to like a treatment per se, perhaps would get a different score. So if there exists a difference in student score as a result of an intervention program, then you would select the alternate hypothesis. If there is no difference between the students who are exposed to the intervention program and the students who are not exposed to the intervention program, you would have to accept the null hypothesis. So the difference between these two hypotheses is that one is saying, the null is saying that there is no difference between the control group and the treatment group in the case of an experimental research, while the alternate hypothesis is saying that there is going to be a difference between the scores as a result of the intervention program which is being used. In the next lecture, I will go on to hypothesis testing. Thank you very much.